Okay, I guess we're going to get started. So thank you very much for joining us this afternoon. I know everyone's got busy schedules, but in this crazy world, I hope you're not all too tired from staying up last night and listening to election results or watching election results. Maybe by tonight we'll actually have some answers. Anyway, today is all about smart work zones, and you can see the graphic on the screen here. We're going to take you on a bit of a journey today, talking about smart work zones. And before I do that, I just want to say a little something about Stinson, Stinson Owl-Lite, Stinson ITS. So I'm the president of Stinson Owl-Lite, and Stinson ITS is a division of Stinson Owl-Lite. Many of you would be familiar with Stinson Owl-Lite. We're the largest traffic sign manufacturer in Ontario, and we've been working with work zone safety equipment, work zone safety traffic management for 60 years. Start in 2021, we're celebrating our 60th anniversary, so we're really excited about that. And something we're really excited about is our ITS division. So we started our ITS division about 5 years ago, right around the time the Pan Am Games was on in the Toronto area, and we actually were lucky enough to work on a few contracts with the Ministry of Transportation in the Greater Toronto area, developing and deploying smart work zone technology for sort of the first time it had been deployed in a big way in Ontario. So we actually realized it was a focus we wanted to take our business on. And so we started a whole division called Stinson ITS, and now Stinson ITS is into a whole bunch of things: intersection sensors, roadside sensors, traffic management systems, software, as well as obviously smart work zones. So before we get started, I know not everybody's familiar with the interface we're using today, the GoToWebinar. There is a chat function on your screen there. So at the bottom, there should be a little chat drop-down thing where you can type in a question there. You can sort of decide if you want to send it to everybody or to the organizers. But we want this to be interactive. At the end, there's going to be the opportunity to ask questions. And so if you could just make sure that's working. And we've got a question for you, something a little fun that goes right back to the beginning of the story. This is the agenda. So again, we're going to talk about the evolution of work zones, modern smart work zones as they are today, and some trends we're seeing in the industry. And then obviously we're going to touch on benefits and then sort of where smart work zones are in the future. But before we get there, there's a question we have. Does anybody know what this is? This is an image of something related to the conversation today, and was wondering if anybody up there in our attendee list is aware of what this is. So use your chat function there, and we'll see if anybody knows what it is. We'll give you a minute to try and answer. Nobody seems to know what it is. So Stinson's been around for 60 years, and when I first got involved with the business in the basement here at our location in Vaughan, we actually have a few of these. And this is called a smudge pot. And what it was used for back in the day, before there was patio-powered lighting and solar power, there was actually kerosene lamps, and they would lay these out. These are slightly different model. We had a hard time finding a photo of a series on a road, but these would actually be laid out in a work zone to delineate the work zone, if you can believe it. So actual fire in canisters called smudge pots, fueled by kerosene, was how work zones were delineated and workers were kept safe. So today we're obviously going to show you a lot. We've come a long way since then, and thought that would be fun. Nobody knew what that was from looking at the interactive chat.
Oh, I replied with firewall.
Sorry, Ajay. You jumped in.
Somebody replied firewall as an answer to that.
What did somebody reply?
Flare ball.
Oh, okay, good.
Okay. All right. So I'm going to start with the smart work zones and how they really started. How do we even define what is a smart work zone? In early days, everybody used to say that, hey, if there's a work zone, then we need more visibility, especially the drivers need to be more aware about what is work zone, where the work zone is, and that's how the signs came into existence. And there were different types of signs for different types of awareness that we wanted to have. And smart work zones really started right there, where there were just too many signs on the road, and people wanted something which was electronic. James, can you hear me properly?
Yeah.
Okay. So there were signs like these on the right side, which were replacing the signs on the left side, and they had two distinct advantages. One of the advantages they had was, one, there were a lot less signs like that, so people were giving more attention to them. And second was, when people see these, they feel that this is more current, this is something which is happening right now, so I have to be more careful about them when drivers see them. While the static signs on the left that you see stay there almost 24 hours a day, and drivers don't necessarily believe that there's somebody working in the zone right now. So that zones really started. The first step of it was just more visibility using LEDs, some of the signs, and using some of the beacons. Can you go to the next slide, please? So the next generation of smart is where the real evolution of smart work zones started. This is not just a replacement of the sign, this is something which the signs could not do. For example, on a sign here on the left, you could tell that Highway 401 is closed, but you could not tell on a sign how much time does it take to cross the highway. While on a variable message board, along with some sensors and some data processing, you could actually calculate this on the fly and show it to road users. Similarly, a static sign saying slow, there's work zone ahead and there might be stopped traffic is not good enough. When you can actually give information about when you can find whether vehicles are stopped and give that information live to drivers which are approaching that position. And this is something which is the second generation of smart work zones. You see a lot of cones in work zones today, but there are smarter cones available as well, which can not just, which has a small radar, a small 3G modem, and it doesn't just give the visibility to drivers, but also gives some of these work zones locations on Waze and Google Maps. These three systems that I've been talking about have been in existence for a long time now, probably around 15 years, and I'm sure James is going to talk about them in the next couple of slides. Yeah, but the most biggest advantage of this now is that smart work zones are no longer just flashing beacon. They are smarter. They can do a lot more. They can sense using sensors and can display messages which are very relevant to drivers at that moment.
Great. So I don't know if many of you have seen something called the Hype Curve or the Gartner's Curve, but the smart work zone sort of industry followed this curve that started with a technology trigger. Then there was a peak of inflated expectation, a trough of delusionment, and then a slope of enlightenment. So back in 2000, 2004, there was a lot of excitement about smart work zones and what was possible. There was new technology coming online. Back then, it was 3G modems that were being put into new devices that had never been really thought of as being connected or sort of IoT devices in the past. So there was a lot of excitement about it, to the point where we saw some projects where they were piloting even using some of this technology to incent contractors to build faster, safer by using this ITS technology in work zones to ensure safety and traffic flow through the work zone. There was also, if you see the cloud there where it says VTOC, that stands for Virtual Traffic Operations Center. There was some real excitement in the private sector because all of a sudden we could connect to devices that may be owned and operated by municipalities or provincial governments, where we could say almost have management and maintenance as a service package for them. So there was a lot of excitement around that early on because everything was connected. The issue with that is, and we'll get to the next slide, which will show you sort of some of the technology that's stuck, I guess, and persevered through this trough of delusion, is the technology wasn't quite there yet. So the concept was there. The idea of managing traffic this way was there, but there was issues to do with power systems. Solar power wasn't quite good enough yet. Battery storage wasn't quite good enough yet. If we were in an area where we could deploy these systems where there was good cell phone coverage, that was great, but often these jobs would be called in rural areas. And back then, even in Southern Ontario, where we operate, there was substantial gaps in network coverage. So we had this concept, we designed these systems, we were super excited about these systems, and then we realized it didn't really deliver well for our customers. So we ended up going back to what we call finger poking, which is if you look at that PVMS on the diagram there, there's a control box in that portable message sign where we can actually type in a message. So at one point, everyone thought the whole industry with it was going to turn to connecting everything online, and no one was ever going to use their fingers ever again. And what we found was it wasn't quite ready for prime time yet. And then back then, sort of on the plateau of productivity, we were still just using static traffic signs and what we call a flasher. That's that device with a battery-powered light on the top. But as with any new technology, there's some things that happen and to make things work better, and some of the pieces sort of persevered through it. And now we are looking at a different hype curve. So some of the older items have become standard. You see there the crash truck with the little symbol is connected. So the crash truck has a connected arrow board on it now. We're seeing that very commonplace. We have Bluetooth connected message signs, and we're going to get into showing how that works a little bit more, where we're doing travel time. So travel time used to be strictly the domain of the big municipalities or the big provincial entities that invested in, were early investors in that technology. Now we can do that. We can do that very easily, have it portable power, and deploy it for short and long-term contracts rather than always needing to do that only in long-term sort of permanent installations. And right now we're just that the cone with the little device on it, we're seeing that technology is pretty robust, but we're just seeing different use cases for it. I think some of the first use cases we saw for it haven't worked out as well as we thought, but we're now seeing different uses for that by identifying job sites, and I'll get into that a little bit later, potentially for autonomous vehicles. And then an interesting one for people in our world in Ontario is the camera icon there is actually where it says ASE is automated speed enforcement. So in other jurisdictions, particularly in Europe and I believe Western Canada, automated speed enforcement in work zones is a really important tool in smart work zones. There's a bunch of policy reasons and that hasn't happened in Ontario, but the technology is advancing pretty rapidly on that, so they can do portable, temporary, automated speed enforcement. But right now, the expectation for that was very high in Ontario, but because of some policy issues and some other sort of political reasons, it's not happening. So we hope to see that move down the curve and and make it to the slope of enlightenment soon. So, yeah. So the bottom line is, through this whole transition in the industry, there's been sort of, we're sort of calling out 4 technologies in smart work zones that have really become sort of the staples of smart work zones in our market. There's a few others in North America wide that we don't currently participate in Ontario. There's something called a dynamic merge system, which is, some people call it a zipper system, where vehicles will approach a merge point, and it will be dynamic. So there will be a series of signs that tell people where to merge, and instruct drivers, rather than everybody going to the end of the merge to merge at the end. It's actually instructing people to, or people merging early because they're trying to be polite Canadians. It actually instructs people to go to a specific merge point and merge. There's a way to manage that merge point to make it the most efficient place to merge, using roadside sensors and signage that is dynamic. And there is also, in other jurisdictions, variable speed limit signs. So you can set up a system of sensors and digital signage that allows you to actually meter the speed of the roadway in work zones based on the volume of traffic, based on if a worker is present or not in the work zone. There's a couple of other things. Those are 2 technologies that we don't currently do in our market, but we do see in other places in North America, and we'll see if they come here. But the 4 that actually do stick and we see called out in jobs in Ontario on a regular basis are automated truck entrance signs, automated queue warning systems, automated travel time systems, like you see here on this on that icon, and then the proliferation of connected technology, sort of everything on the road and everything on the job site connected. We'll get into more detail. So Jay is going to get into the specifics on 3 of those systems, so you can all understand how they work.
James. Yeah, so as James mentioned, that these systems are very widely accepted and used in, at least in Ontario. The first system that I'm going to explain is about truck entry and exit systems. We call it the TC31A here in Ontario. It's a very simple system where you have a detector station, practically a pole with a sensor mounted on it. Sensor could be a microwave sensor, could be a radar detector, and usually it's powered by a solar panel, and it has batteries down here. So this is very portable. This could also be mounted on a trailer here, so you can move it depending on how your construction phases are going. It detects trucks merging onto the highways or coming off the highways, and then you can have flashing stations. So there's a radio communication from the station to the flashing station, and the beacons start flashing as and when you have a truck either merging onto the highway or coming off the highway. Especially when the trucks are merging onto the faster lane of the highways, this is really important to use them. It's a very simple system. It doesn't connect to a kind of central control room, something like that. It's just a system which works locally. The distances could be up to 300 meters, and if more distances are required between the detector station and the flashing station, then there's always the possibility of adding a radio repeater. Also, there could be multiple flashing stations, instead of just one flashing station, just in case you want to make your drivers well aware of what's happening, what's going to happen in front. The next system that I'm going to cover is the automated time travel system. These systems are a little more smarter than the TC31A that we just covered. And the principle is still very, very simple. What you do is you use a sensor to detect vehicles at one location, and you also use a similar sensor to detect vehicles at another location, let's say after the work zone. the initial and the final destination for what you want to calculate that travel time for. We usually use Bluetooth and Wi-Fi sniffer to detect Bluetooth and Wi-Fi devices which are on the car, and we match the devices on a cloud software so that we know, okay, this vehicle was at location here at time, let's say 12:31 p.m. and it was at location, the next location at 12:35. So it's about say 4 minutes of travel time. But it's not just based on one single vehicle. Over a period of time, we look at a bare minimum number of vehicles that has to be there to be changing the message signs here. So a lot of options are available. It's a very simple system. Put some sensors, calculate the travel time, and display it on the variable message sign board. There's also a possibility to access the travel times later on using a web software. And you can also generate email alerts, especially if the travel time is above value, and you can let your emergency services or your traffic management people know about this. The next system that we'll talk about is the automated queue warning system. This is a little more complex than the previous system because it uses multiple sensors, and this comes into two different configurations. The first configuration is a semi-permanent system where, let's say you have a long-term construction job going on a highway, say 2 or 3 year construction, you know that it's a 4 or 5 kilometers or say a 10 kilometer stretch. Then you install, and especially if it is a highway, when you have multiple lanes, let's say more than 3 or 4 lanes, where you want to look at queuing or stopped vehicles over multiple lanes, then you install a larger sensor. We use Houston Radar SpeedLane Pro. This kind of detects the speeds of vehicles which are passing from in front of the sensors, and we space them, say, every half a kilometer or every 1 kilometer, depending on the requirements of the project. And as these sensors see a speed dropping from, let's say, 70 kilometers per hour to, say, 35 or 40 kilometers per hour, then the cloud software is able to process this data and show a message saying slow traffic ahead. But if the speeds drop below, say, 10 kilometers per hour, then the cloud software gives a message saying stop traffic ahead. Again, a very simplistic system, but you need to install all these sensors. You need the power at the location. Normally, they're all powered by solar power, especially because they're temporary installations, and again, have a VMS trailer. The software can also be accessed via the web, so you can see how many how many times in a day slow-moving traffic happen. You can also see the frequency and the locations of slow-moving traffic or stopped traffic, and you can also give email alerts to your emergency services and your traffic management staff. But let's say, what if the job is for a shorter duration, maybe 2 or 3 days? It's not worth putting some of these large sensors on a pole or a semi-permanent kind of a system. This is where there are options available with battle-mounted sensors that you can see here on the right, where there are radars in there. There's also LEDs so that they are highly visible even at night, apart from the reflective tape that is around there. But these radar sensors again detect speeds of vehicles passing through them, and depending on how the speed is, the message of the message signboards change. The biggest advantage is some of these temporary systems can be set up in, say, half an hour to 1 hour's time, and even if it's a couple of days job, you can put it in there and get them back. They're all battery powered. There's no real solar power in here yet, so it's really easy to install them, really easy to use them, and they are very popular right now. James, would you like to talk about the connected work zones now?
So another trend we're seeing right now and is sort of the concept of the Internet of Things coming to the work zone and connecting everything in a work zone. So we work with a company this specifically on this one that is integrated with Waze. It's called iCone. And they've developed some sensors that can be mounted on trucks, guardrails, even in flagging inside the stop slow paddle or a flagger. And the idea here is that as we moved across that curve, almost anything that can be powered can now be a device that is a sensor in a work zone. We'll get into exactly sort of why you would want to do all that from an operational perspective. But I think what we're seeing is it's moving quickly into what else can we do? What else can we connect? What else can we get visibility of? And how else can we improve the work zone for the workers, and the drivers, and then the public that is trying to get home at night faster? So we put all those things together, and we are able to do some really interesting things with connected systems. Particularly, some of these are automated. So on the TMA trucks and on the guardrails, these sensors are automated to the point where there's no user interface required. They sit there, the sensors sit there, calling home and giving location data or status data, whether the TMA, the truck mounted attenuator is in the up position or the down position, or what direction the arrow is facing on the arrow board. That information is fed back to a central management system automatically with no user interaction. So we're seeing this being asked for by some of our customers, and it seems to be the direction it's going very quickly. And particularly with this, everybody's trying to figure out how this information is going to get consolidated and be sort of pumped into the vehicle. And so this is one way we're seeing success right here is with this with the Waze integration. So the work zone comes up automatically on the Waze app, and then any drivers that are using the Waze app on their Apple CarPlay or Android Auto, it's automatically there. So it's a pretty interesting way to do it and connect everything, and obviously very user friendly. So a little bit of what Ajay talked about, the recent trends we're seeing is short term. So the iCone that you see there is the orange and white one, and then there's a product called SpeedMac from Firmac, which is a Canadian company. When we're doing, in the past, these were for long-term jobs only. Now we're seeing them used for weekend work. Where a good example is last summer, there was a rapid bridge replacement on the 400 highway north of Toronto, where they replaced a bridge in a weekend, and they needed to notify the public of the complete closure of the 400, but they also wanted a queue detection system there. So to reduce the chance of anybody getting in an accident at end of queue. The issue at the end of queue, and just to go into a little bit more, is there have been some very horrendous accidents recently in the last sort of 5 years where a vehicle comes upon stopped or very slow traffic over the crest of a hill, or it's somebody who's been driving long haul trucking and they're not quite paying attention, or there's distracted driving issues. There's many times where a queue end warning system can prevent horrific accidents. The next trend we're seeing is a lot more interest in the incident response world. So whether you're closing a lane or responding to an incident for 10 minutes or 10 days, while you're there on the road and your lane is closed and traffic is going by, you're in as much jeopardy as if you were there for 10 days. So we're seeing a lot more interest in the incident response world for some of these devices, getting their vehicles online and noticed, as well as installing camera systems and other integrated systems where we're installing sensors and devices in vehicles, capture data for a number of reasons, not necessarily just traffic management, but also for insurance reasons and operator compliance issues. And then the next thing we're seeing, which is sort of a segue to the next slide, is we're seeing a shift from smart work zones really being the focus of freeway management and freeway construction sites to a more urban focus. And so in the past, municipalities, large and small, might have a fleet of message signs that they would use. They might finger poke them to say road is closed, or there's an event next week, there's a parade or something like that. But now they're starting to realize that this technology is getting easy enough for them to manage themselves to a certain extent, as well as integrate with other systems they already have. So this trailer here is actually a photo of a portable message sign that was developed for a large municipality in Ontario, and it is a sort of became a power platform for a camera system, a Bluetooth travel time system, as well as a message board. So this is now sort of a three-trick pony that can do a bunch of stuff, and it integrates back into their sort of main traffic management system. So it's sort of just a field device, sort of a multifaceted field device for them to use. So we're seeing sort of, I guess, as the industry matures and smart work zones become more understood, we're seeing municipalities sort of multi-purpose some of their existing fleets. Because a lot of this stuff can be added to fleet afterwards, or we're seeing in procurements that are happening now, we're seeing more and more technology being bundled and added to these platforms to get more out of, I guess, their investment in equipment. As well as just straight up smart work zones and understanding work zone traffic patterns and safety issues. We're seeing that shifting in urban construction projects. And I think Ajay is now going to speak about one in particular.
Yeah, little conscious about the time here, so I'm going to be very quick about this, but we are seeing some really innovative approaches by some of the constructors here. One of the construction companies we work with is constructing LRT job in Toronto, and they're using video analytics to take data-driven decisions. They're looking at turning moment counts, and they're also looking at traffic data on the corridor so that they can decide on closures of lanes and even driveways based on the actual traffic that is happening, especially during the COVID times. This has helped them accelerate the projects. They're also using video analytics, not just for CCTV surveillance, but also to identify, if there is an incident and they need to respond back to that. Some of the things that video analytics that our partners are helping them with is they're looking at a lot of blocking the box incidents, especially at important intersections where there's construction going on. So they would like to know how many times does this happen, and what is the time at which this happens the most, so that they can have traffic control measures during that time. And if we can automatically detect that, just like we automatically detect vehicles in the boxes here, which are the video. James, can you run the video, please? Yep. So as you can see, if a vehicle comes within this zone, the green zone, within the yellow lines, the zone becomes green if a vehicle is there. Also, if you see on the top right video, the vehicles are getting counted as and when they pass through the intersection. They're using this data, and they can make similar zones on the box so that they can detect if there's somebody who's stopping there or not. And we're working with this LRT Construction company to ensure that all of this data, plus the data from the Bluetooth and Wi-Fi travel time system, comes at one single platform, and they can take decisions about project acceleration or even decisions about traffic management. I'm going to show you a dashboard on the next slide. This is the dashboard they see. They see the travel times from one location to another and from another location to one. So there are multiple travel times that they can see. So they can monitor this real time. They can also monitor this on the map. What are the green zones? What are the red zones? Where is it that they need to focus on, and they can see CCTV footage from 8 different cameras, as you can see here, and you can switch the cameras on the on the places below. So it's very nice and easy for them to see, but they also look at data analytics. Like, for example, James, can you go to the next slide, please? For example, we share monthly travel time reports from the Bluetooth and Wi-Fi system with them. For every single hour, what was the travel time on which day? And if you look down, you'll also see whether it was a Saturday, Friday, Thursday. And looking at this data, especially looking at data from Sundays, you would see, especially on the 11th of October, you can see that they have scheduled a lot of construction activities on Sundays, and sometimes they schedule a lot of construction activities on Saturdays. You'll also see that they do more road closures at night than compared to the day. Friday evenings, if you see a high travel time, it's probably because there was more traffic at that time there. But even monitoring some of this and then taking decisions based on that is fantastic. This is a new trend that we have seen, and they're willing to do more innovation just to find out more about compliance in a work zone. Now James is going to talk about how the benefits are.
Yeah, so we go back sort of the story at the beginning and the why and the benefits of doing this. It's all listed there. It's relatively straightforward. From traffic operations perspective, we're creating a more engaged driver by providing real-time relevant information. So that's helping with safety, and as well as the enforcement people know what's going on. There's a dashboard with a lot of these systems. So from an operational perspective, you can look at compliance. If you're a road authority, you can look at compliance potentially of your contractors. If you're a contractor, you could be looking at compliance for your employees or your subcontractors, as well as some of the systems have some integration with emergency services, so they know where to go and where not to go during construction, which is a huge issue. They need to know in real time. What we're seeing is, from a traffic operations perspective, many times road work is a scheduled activity. So with some of the systems we see, it will say that construction is happening between here and here on this day, and that will be posted to a public website somewhere. But then in reality, construction doesn't happen that day for some reason, or construction gets extended at that location past the scheduled day, and it doesn't get updated on the public portal. So these devices and this technology gives us real-time information that can be shared. Project management, we touched on that a little bit already. That's pretty straightforward. And then road users, obviously, understanding, getting information, planning alternate routes, keeping them informed, gives them more satisfaction, I guess, customer satisfaction. They look at customers while we're disrupting their world and trying to build infrastructure. It's important to keep them on side. We won't go into it again, but obviously the cloud and the connected apps that make it all possible as part of the communication piece is vital. So the future trends, we see, obviously, right now we're driver focused or sort of mobility focused. We're trying to get information to drivers to identify hazards, give them information so they can make better decisions. And we're trying to drive work-based compliance. People slow down through work zones, all that type of stuff. So obviously what we see in the future is the automated connected vehicle interface is coming. So some of this technology will get connected directly to the vehicles. Rather than people needing to understand what's going on, the vehicles are going to have to know what's going on. And the vehicles will start making some decisions, routing decisions, speed decisions, safety decisions on their own. So that's part of this. Part of this is trying to understand where this is all going. Another interesting thing is that little crash truck, that icon down at the bottom there. You can't read that. I don't think you can read the verbiage on the back end of that truck-mounted attenuator, but that is actually a fully autonomous truck-mounted attenuator truck. So that truck will drive down the lane with no driver in it. And there are a number of pilot projects happening in North America and Europe. Nothing that I know of in Ontario yet, but we're seeing some high-risk jobs like driving a crash truck being moved over to sort of an autonomous vehicle. We can see that coming. So yeah, so it's moving from a driver focus to a vehicle focus. We think that that curve is going to be pretty long, but there is no question the pieces are sort of getting put in place to do that from a policy perspective, protocol, sort of software protocol perspective now for the next sort of decade. So again, this is the conclusion, and it's pretty obvious now. Modern work zones are connected, they're reliable. I think that's something that's really important to understand. This is proven technology now. There are a number of companies that do this type of work. So the market has matured, it's become much more affordable. We can do short-term as well as long-term work, smart work zones, and urban as well as freeway deployments now. Benefits we've gone over: safer, we want real-time info, and the big thing that Ajay was going over when he was showing the video system is the data-driven project management. That's a bit of a new thing. So everything was very much reactive tactics, safety focused before. Now we're seeing a much more data-driven decision-making process happening in smart work zones. And then one of the side benefits is fleet and equipment management. So it's more of a lower level thing, but now that all these devices are connected, we know when something is malfunctioning. We know when something needs service. Most of them have some sort of a diagnostic piece built. So I believe that that's the conclusion. There's a couple of other resources, and I believe you'll be sent a copy of this presentation. These are both US-based, but in particular this workzonesafety.org, the National Work Zone Information Clearinghouse. There is a ton of information about connected work zones, smart work zones there, as well as the Transportation Research Board has a lot of information. Again, both US-based, but a lot of it is very transferable to Canada and to our market. And now it's questions. I don't know where the question is. If I can see it properly, but are there any questions?
You can see the questions. If anybody has any questions, please type it in, and I'm going to read them out to James. By the way, James, Tim Cox is somebody who had written the correct answer for the smudge pot right in the beginning. I'm sorry, we didn't see it at that time. We have a question from Kevin, who asked, is it possible to describe the process for getting a work zone designed?
Can you try to say that one more time, Ajay? I don't see the question.
Is it possible to describe the process for getting a work zone design? Anything about work zone design?
Sure. It depends. Obviously, it depends on the work zone. There's an infinite number of different layouts. We sort of start with our craft manual, book 7 in Ontario, which sort of designates how work zones are set up. But then there are some guidelines with regards to distances between message signs, distances between sensors, depending on what type of smart work zone we're doing. We do a proposal. We do a site check, and then we do a proposal on sort of what we're trying to accomplish and what tactic we're going to use, whether we're going to use travel time or queue warning or what it is that is going to help the most, and potentially be a combination of those. And then we would put together a proposal for the customer, and it's sort of half and half. Half the time we do a proposal, and then half the time it is sort of delivered to us by an engineering firm where they say, this is what we've done the work and we want you to deploy this on behalf of the contractor. So often companies like us are working as a subcontractor to the general and managing their smart work zone deployment and maintenance. And so, but we definitely have the ability to help in that design sort of stage. I hope that answered it.
We have a very interesting question from Graham, and he's asking, is there anything that can benefit smaller budgets on private development projects, not municipalities and governments? Private development, anything from smart work zones that can benefit them?
Yeah, there's some. I mean, we've seen some private, not necessarily work zone projects, but portable. We've done some portable speed camera work that is based on a smart work zone technology, where we have speeding issues going through private property, where we set up a non-enforceable speed camera system where we can track with license plate recognition. We can track speeds and identify vehicles. More to, I guess, prompt a stern warning and a conversation with HR potentially, rather than an actual fine or any type of enforcement. So yeah, and then again, it's one of those things that if you get to know the technology a little bit better, we're using sensors to track vehicle speed, track vehicle identification sometimes. So there's lots of different warning systems that can be created by integrating these tools all together. And I'm not sure that answers it exactly, but private property usually is a little bit more under control. But we've also done some work with some Bluetooth sensors. Bluetooth has become a very inexpensive way to track time between point A and B. So if there's a need for that in a private setting, that's a relatively inexpensive and easy way to do that. And again, I don't know if Ajay said that data is always very autonomized. So we don't know who. We just know that a vehicle and then the same vehicle. We don't know who. We don't identify yet.
We have a bunch of questions now, James. I'm going to read them very quickly and let's answer them in short because we are short on time. We already crossed the time that we said.
People are going to talk about this all day.
The first question from Mike is, have you seen connected work zone technology in Canada, used in Canada so far? And are these called in the contract or proactive measures? Right? Are they a part of the contract or are they proactive measures?
Yeah, so connected work zone, yes, absolutely. We see them called in contracts on a regular basis. Particularly Bluetooth travel time is very popular right now. We've seen key warning systems called in a number of contracts. We've done some deployments. I mean, we're based in Toronto, or north of Toronto, so most of our work is in Ontario. So we also were involved in a project sort of arm's length in Alberta. So yeah, some of these systems are being widely used. Yeah.
Perfect. I'm going to answer the next question, which is from Jason. Are there any concerns about cybersecurity of the connector systems to combat or protect against abuse or potential liability? First of all, most of these systems do not store any personal information. All the information is hashed right at the time the sensor detects the information. So there's no personal information available to the cloud software or anywhere else to anybody, including us who are vendors to such technologies. Second is there is enough encryption at the device level, at the communication level, and at the cloud level, where only authenticated users can enter the system, and it is SSL 7 level protection, which is the same level protection that you have with your banking systems. So it's very secure, and of course, everything is encrypted. So somebody gets access to that data after spending millions of dollars, then it's not going to be very useful. I'm going to read the next question, James, which is from Kevin. With the data collected, do you work with the end user to make adjustments as required for the data collected? So do we change our systems so that we customize them for different customers? I guess this is what the question is.
Yeah, so yeah, absolutely. Some people are using data for their traffic management. So they may have they have an engineer or people on staff that will use that data and interpret that data and change things. And we've also, we're in situations where we're using that data to dynamically change things. If it's a key warning system, we're dynamically changing the distance to the queue. And there are systems that are able to adaptively change traffic signal timing. There's some other things that can be done automatically. Yeah, right now, what we'll do is often the job site as designed by the engineer is the starting point. And then we deploy the equipment for a certain amount of time, and we find out the reality of the situation may be a little different. We're seeing merge points in a different place than we expected. We're seeing longer queues than we expected. And we can adjust on the fly, move equipment around, adjust where sensors are. Yeah, we do that on a regular basis.
James, there are more than 10 or 12 more questions. I'm going to take 2 more, and we promise that for each one of you, we'll reply personally to all the questions that you have asked here after this webinar is over, most likely tomorrow morning. One of the first questions that I'm going to ask you is from Nilesh. As a project manager, can we have access to monitor real-time message on PVMS on their PCs? And I can answer this. As you saw on the on the dashboard that we showed, maybe James, you can go back to that, the dashboard. So this is the dashboard, and you can see that these are the actual PVMS messages which are shown on the PVMSs located on the roadside. So time to Martin Grove is 4 minutes. All of these are messages. So you can not just monitor real-time messages, but you can also see historical messages that were being displayed at different point of times.
One thing, Ajay, I was just going to say, this can also become temporary infrastructure. So often we see construction projects where they've taken out existing, maybe permanently mounted message signs, or permanently they've taken down their camera system for the construction project. So this can also be their system while the area is under construction. So you can also pipe things like Amber Alerts, or there's some sort of city management things that can come into focus here. It doesn't have to be exclusively about the work zone all the time. It can be used for other events or other information you want to pass on to the public.
Okay, last question for today is from Dario. He says, we talked about smart crash truck. He is very interested in understanding how will a crash truck autonomously work without a driver, and how will it move through a work zone, or will it be parked at a certain spot and as a crash cushion when necessary. So would you want to talk a little bit about that? How does that work?
Sure. So to be honest, it's very early days in that technology, and it's the policy and the procedures around it haven't been created yet. So far, the demonstrations that we've seen has been where they have 2 crash trucks sometimes in a line when they're doing pavement marking, or it will follow almost like a breadcrumb situation. It will follow the first crash truck that is actually dropping the cones that has people on it, and so it's almost a buffer vehicle protecting the truck in front of it. But again, it's early days, so there's been no sort of development of policies, and it's more just testing that it's possible and reliable enough to be taken to the next step. But I think the intention is to protect workers, so get the worker out of it and protect them. I think it's being used primarily as a secondary buffer for the actual truck that has workers.
Okay, I think that's it. Do you want to go to the last slide before we say goodbye? Yeah, so go ahead, please, James.
I was just going to say, so our next webinar, so first of all, thank you for anybody who's still here. Looks like there's a bunch still here, which is great. Our next webinar is on the 2nd of December, and it's obviously what you see here. It's about Genetec Intelligent Mobility. So we've got Christian from Genetec and Michael from Stinson ITS, talking about a little bit more in depth actually about the that dashboard that we showed is actually a Genetec system. So we're going to talk a little bit more in depth about how all the sensors and devices and signs work well with this operating system or dashboard system, as well as something that's very interesting is sort of workflows. So if this, then that. So if something happens on your work zone, what do? You can actually design workflows within the software to tell you exactly how to react and what to do for incident identification, validation, management, and then how you can use, if you already have a video management system, how you can use Genetec to help with that situation. So should be good. Christian is very, very well versed in Genetec. And Michael is our leader of the Stinson ITS department. So two heavy hitters for the next one coming up.
Thank you, everybody.
That's it. Should I just say thank you? Well, I guess there's another slide. So yeah, so thank you very much, everyone, for sticking with us and attending, and look forward to the next one. And obviously, please do not hesitate to reach out to us. Our email addresses are there. They're pretty straightforward, as well as we'll be in touch with a summary of the presentation and some of those lingering questions we didn't get to. We'll make sure we answer those questions to the group. All right. Thank you, everyone. Have a great day.